Good afternoon and welcome to all attendees today to this webinar on enhancing safety and reducing fire risk in residential and commercial solar PV and battery energy storage systems. My name is Chris Yelland and I'm the Managing Director at EE Business Intelligence, and I will be your host at this webinar, signed in from Johannesburg. Welcome also to our presenters, who will be introduced to you in due course. I will share a link with you now on the Zoom chat facility where you can all download presenter biographies if you haven't already got them at hand. And welcome to you, the attendees, for your interest and participation today. This webinar is hosted by EE Business Intelligence. I would like to acknowledge and thank the South African Bureau of Standards, Extien and Leroux Electrical Engineers, the Electrical Contractors Association of South Africa, the Heralds Group, Go Solar, Hawaii Digital Power, and Leon Ruiz for their valued support for this webinar and for the great work they do in this field. Over 1,400 delegates have registered to attend this webinar to hear what the presenters have to say on the subject. This, of course, attests to the relevance of the subject matter being covered, as well as to the stature of the presenters. So may I thank the presenters up front for their hard work and participation, and for the time and effort that they have put in. Please do note that this webinar is being recorded, and links to view the webinar on demand and to download all the presentations will be made available tomorrow morning at about 9 o'clock to all those who registered to attend, as well as publicly. Colleagues, as rooftop solar PV and battery energy storage systems proliferate across the residential and commercial sectors, safety and fire risk mitigation have never been more critical. This is an expert-led webinar that tackles the latest strategies, technologies, and best practice for improving system safety and reducing fire incidents on customer sites. Key topics covered include the pros and cons of power optimizers fitted to solar PV modules to reduce rooftop DC voltage close to zero under emergency conditions. We'll also cover DC arc fault detection and circuit interruption to reduce fire risk caused by DC arcs. We'll cover best practice in respect of positioning of battery energy storage systems on a customer's premises to minimize fire risk. We'll also look at battery cell quality control and manufacturing and assembly processes that minimize cell failures and thermal runaway within battery packs. Integrated fire detection and suppression within lithium iron phosphate battery packs will be considered to reduce the fire risk. And finally, we'll be looking at the regulatory and installer practices in residential and commercial solar PV installations that are required for these installations. The program for the day has been widely circulated already, but a link to download the program will be shared again here now on the Zoom chat facility for all. So please do take a look at the chat facility where you can download the presenter biographies as well as the program for the day. After an opening address by the convener of the SANS 10142-1 working group, 4 expert presenters will each have 20-minute slots to make their presentations, and in between we'll have a 10-minute comfort break. This will be followed by a wrap-up by Leon Ruiz with some insights of his own. After this, we've set aside about 30 minutes for our presenters to answer just some of your questions in an open discussion and Q&A session. While the presentations are in progress, please do send us your questions on the Zoom Q&A text facility, not the chat facility, the Q&A text facility. You may also put up your hands during the Q&A session to ask questions verbally. And if we got time, we will certainly get to those as well. So without further ado, I will now introduce Andre van der Elst, who will deliver the opening address. So Andre, if you can share your presentation now, switch on your camera and microphone while I introduce you. So Andre graduated from Potchefstroom University as an electrical engineer. His career spans over 42 years at companies in the electrical sector. For the last 19 years, he has provided consulting services at Eckstein and LaRue Electrical Engineers as both partner and director. ELR, or Eckstein LaRue, designs, develops, and implements solutions in electrical reticulation at high voltage, medium voltage, and low voltage, and both bulk and link infrastructure, and with solar PV playing an ever-increasing role over the past years. He has also served on various SABS subcommittees and work groups relating to HV and LV switchgear, electricity distribution, and electrical installations. And for the past 31 years, as a member on the SANS 10142-1 wiring code work group. And for the last 11 years, he has served as the convener of this work group. So it's a great privilege for us to have Andre speak to us today as an expert and as the convener of the SANS 10142-1 work group. Over to you, Andre.
Thank you, Chris. Can you just tell me that you can hear me clearly?
100%. Thank you, Andre.
Thank you. We had a practice session, so that has definitely reaped some results. I am indeed humbled, Chris. Thanks for asking me to talk to the technical community, your listeners, the delegates of today. It is a privilege. Yes, I said 31 years in the correctional services world. That is more than a life sentence. But although it's not always fun, it is a privilege, and I think one needs to give back to the industry, and that is also what I'm trying to do with it. So I will start my presentation with my first slide. Just to say what the focus of the address is, it is really high level. It is not intended to bombard the audience with facts and figures. I want to give a very brief regulatory framework and status quo in respect of today's discussion. And my focus, you must just keep that in mind, is I'm not a legal person, I'm a technical person, and the point of view will be from the wiring installation perspective. So there could be other perspectives, but I'm going to look on the customer side of the meter. And I've posted here a snippet from the, let's call it, artificial intelligence world, and I'm going to read it quickly. Based on this last year and this year data, the total invested capital in private SSEG, which includes households and commercial rooftop solar, has experienced a rapid growth, with a total installed base of private rooftop PV exceeding 7.3 megawatt, 7,300 megawatts, or 7.3 gigawatt by late 2025 last year. Now that is more than a power station. We know it's not 24 hours available, but we also know that batteries helps us with that. So I'm going to give a bit of background on the wiring code, because that is where my expertise for today lies. It is firstly a document that has got some legal status in our framework of legality in this country. The document is maintained and it's updated and renewed by a working group where I'm a member of. Our working group reports to a SABS committee, a technical committee, TC67, and there's a subcommittee, SC06, responsible for wiring installations, and industry is represented thoroughly. I just want to make sure that you take note that Eskom is in the subcommittee and technical committees, AMEU, so from the supplier side, the contractors, ECA, ECSA, XR, the engineers, ECB contractors board, manufacturers, Department of Labor, I've not listed them, and consultants, etc., etc. So it is democracy, or let's call it technical democracy, practiced in this structure. SABs then manage the standards development process, and there is an act that governs this process. We, as a working group, comprise of the SAB Secretariat. I say 25 up to 40. 40 is the absolute maximum. It's quite a task, I can assure you that, but it's also a privilege to work with, certainly, I would say, a lot of specialists in various fields. I just want to add on the first, to unpack the first item of the previous slide that dealt with the legal status. And what I'm showing here is a notice by the in the government in 2009, where it is declared in the electrical installation regulations. You can see it there, 2009, referring to that that the last on the last sentence there is in is 1042-1, the wiring on premises part 1, low voltage installations, is then incorporated as a safety standard into the EIR, thus into the OSH Act, and that is where the legal status is coming from. I also just want to show you that in the EIR, or the electrical installation regulations incorporated in the OSH Act, the definition for electrical installation refers to and wiring or installation from a point of control to a point of consumption, and similarly the SAN S10142-1 wiring code, exactly the same. So the two documents are speaking to each other. In principle, the wiring code is supposed to be a living document. It has been amended a number of times. We will see just now. It closely follows IEC developments as far as possible. Also, developments within our country, SANS standards. We follow product developments. Sometimes products are developed long before standards have catch up with them, or with the developments. Follow installation norms. We revise safety requirements, and we consider industry input on the code. We can't always give. We have to balance things, and you must keep that in mind. It's a balancing act. And obviously the task of the wiring code working group is to review the code as a whole. So I don't want to spend too much time on this slide, but it took me quite a while to put it together, because I was not born in 1922, and the internet did also not exist. So it was a bit difficult, but I tried, and hopefully I'm accurate here. You can see we started with the Factory Act, after the red code. That is from the 1922s. I more or less started with the green code when I became involved in this 31-year period that I was referring to. And we are now with edition 3.2 is marked in red. That is the current version. So if you refer to a version currently, that is the one that is officially published. We are working on 3.3. Edition 3.3 is a bit of the focus of today, because I want to tell you where we are heading, but also 3.4 that hopefully we will see next year. 3.3 hopefully this year. My guess is by the middle of the year. Okay, so PV solar, or the advent of PV solar, or the popularity of it, triggered the development of a lot of rules. And more or less 12 years ago, it started in South Africa, and we like to do things ourselves in South Africa. We also participate in the international world, but then we do things ourselves as well. So we had an effort being funded by overseas funding to develop a super standard, not by the SABs, but by external consultants with, as I said, overseas funding. That the result of that is not the topic of today, but it was followed up with the SABs themselves, putting a project together to create a document called 10142-1, which is the wiring code dash two. Then that would be the, let's call it SSEG, small scale embedded generator version of the wiring code. It would be a self-standing document, nothing to do with the wiring code. This left the wiring code a bit in the dark because we said in the wiring code we cannot keep on developing the code in the field of, let's call it, renewables if there is a specific standard that will be dealing with that. So we had to hold back our let's call it our development on the renewables. But unfortunately, the voting process of this SABS SCCG document, if I may call it like that, the voting failed, and the subcommittee then delegated the task to Working Group 01, which is ourselves, the Working Group for the wiring code. We tried our best to collate all existing work. It was quite an extensive document that the previous working group has built up, more than 100 pages, if I have to give a number to it. And we trusted that we could do it within a year, but needless to say, it was not very easy, especially with a big working group at that stage. What I want to show you is alternative supplies was part of the wiring code. It was already part of the early wiring codes, and there was one specific note that Chris Yelland himself had to point to me, is creating a lot of problems because it states, and I'm going to read it out, this part of SANS 10142 does not cover the generation, integration, synchronization of any alternative supply operating in parallel with the wiring installation. So I want to point out to the audience that this note was introduced in 2008 already, long before the word PV or solar appeared in the code. And then unfortunately, sometimes we look at the definition of things in the code, and I just want to show the audience that in the wiring code, notes are in only for informative or additional information. It is not normative. So we never considered note 2 normative, but it was also never, let's call it, updated or checked in the later editions. So it created quite a big problem because the industry at large followed the notice of note 2, and they say not included. So what I want to say to the audience in response to that is that PV was introduced in the wiring code, and the first time in 2017 in the code edition 2, not the current edition, which is edition 3, so it's a previous edition 2. And specifically 60364-7-712 is the IC spec that was scored up for grid-connected PV installations. And that, I need to say, covers parallel operation with the grid. And that standard, although the inverter standards, which are 62109-1 and -2 for parallel systems or hybrid systems, then are called up in 7-712. So all along, we thought we were covered, but I think the perception of a standard is the problem here. So in the mid 2025, you must now keep in mind that the duty to bring the, let's call it, PV and solar into the wiring code was handed to us mid 2024. So a year later, when I looked at the progress, and we met every month, which is 3 times more than normal, the progress was not good enough. And we decided at that stage, based on a proposal by one of the members, that we are going to do amendment only to get rid of note 2 and to clarify it and to add a test report specifically for PV and BES. So the test report, I want to say here, is in terms of the EIR or the installation regulations, shall have, this comes from the EIR, at the a COC, every user or lesser of an electrical installation, as the case may be, shall have a valid certificate of compliance for that installation in the form of Annexure 1 in the EIR, which shall, let the words shall be dominant here, shall be accompanied by a test report in the format approved by the Chief Inspector in respect of every such electrical installation. So we started to work on the next edition, which was edition 3.3. By starting, I say we just tidied it up and we want to publish it. That was mid 2025. We are now approaching mid 2026, so it's a year later. So we wanted to do those two things, but we had to do some other urgent matters that entailed medical locations that was amended, neutral earth bonding at the inverter, quite a big story, quite a bit of debate, and I can say to you currently that we have circulated the amendment, and we expect we attracted a lot of comments, all very appreciated, a lot from the supply industry, which will also be carried forward. And it is definitely going to help us to build the wiring code going forward. So current work in progress is then additional rules pertaining to PV and BES. So we have not completed everything, or we have not published everything just to gain time. And that process took us a year already. So table 4.1 will be updated, as I said, with edition 3.4. And the comments that we received from the supply industry and others will be reworked in edition 3.4 as well. I thank you very much. I trust it will set the tone for what could follow.
Thank you very much, Andre, for that very informative sort of setting for today's discussion, which is really looking at the legal and the regulatory framework and the progress in your work group on the updates of SANS 10142-1, as well as keeping us informed about the abandonment of the standard SANS 10142-1-2, which I think is welcomed generally. Because it was becoming a vast document that was really reinventing the wheel of a lot of IEC standards that have been accepted and overwritten by the South African Bureau of Standards as South African national standards. So these national standards existed and really just needed to be brought into and updated, the SANS 10114-1, as opposed to having a completely new and voluminous document. So I really appreciate that input. And we're now going to move on to our first main presenter, who I'm going to introduce you now. And Anthony, while I'm introducing you, please can you switch on your camera and mic and share your presentation? And Andre, if you haven't done so already, stop sharing and switch off your camera and mic. So to introduce Anthony. Anthony is a master installation electrician and the regional director of the Electrical Contractors Association of South Africa, Highveld section. Since 2007, he has gained extensive experience in industrial, petrochemical, and automation sectors, and he is a dedicated mentor and SABS committee member, and he balances technical leadership with his upcoming BSc electrical engineering studies, supporting the industry through training and advocacy. And for those who don't know, the ECA is registered in terms of the Labour Relations Act, so it has a statutory basis. And it has a membership network of around 4,000 electrical contractors, which employ about 75% of the workforce employed within the electrical contracting industry. So with that, it's over to you, Anthony, if you can switch on your microphone and deliver your presentation. Thank you.
Thank you, Chris. Thank you for the welcome. I hope you can hear me loud and clear.
Yes, thank you.
Great. As Chris said, in summary of what I really am, I'm but an electrician, and I like to look after my industry. and I like to give a lot of input into my industry as much as possible. I do want to thank you for the opportunity to present today. So we're going to look at a couple of things today. I'm just going to introduce us very briefly, the ECA as a whole. We're going to look a bit at batteries and current incidents and look at some recommendations of how we can better industry with regards to batteries specifically. It's an unspoken topic, and it's becoming more and more of an issue, as we'll note soon. So the ECA is, as said, we represent about 4,000 odd members. We've got various terms of service. We've been around for 78 odd years. We've got services that include technical, labor, contractual, as well as bargaining council representation, where our statutory form comes on. We negotiate on behalf of the contractor, as well as various other services. I form part of the technical side of the ECA, so I am part of the technical advisory side. So my job day to day is dealing with complaints, dealing with queries, dealing with everything other than our day-to-day office running. So it's always just good. It's always just good to take that into account. So if you do have any queries, you can relate them to us outside of this. Outside of that, you can also ask questions in the chat, and they will get answered abruptly. So to understand lithium risks and lithium batteries, we have to understand lithium ions. So lithium ion batteries, or lithium iron phosphate batteries, are a makeup of an anode and a cathode, and energy shared between them across a separator, which is normally graphite. So what happens is current moves from one to the other, and molecules move backwards and forwards. I'm giving a brief overrun. There's a lot deeper science that we can go into, but for 15 minutes, I'm not going to go into that in depth. So with that movement of energy, there's always certain risks you deal with the energy, in that energy can be discharged if there are if matters arise that damage, overcharge, etc. Then that energy has to go somewhere. So when you're storing energy, you're always sitting in a place of risk. So when you're looking at how cells are made up, the older form of cells, if you remember your old, what was it, Samsung Note 7, which used to cause a lot of fires, they were in a layered structure on the battery, which created, in effect, an easy way for it to get damaged, overcharged, and for the electrolysis to occur. So as soon as that anode and that cathode meet, they start burning the energy completely. So part of what lithium iron phosphate does is it puts it into a crystal lattice formation, which makes it a little bit more difficult for it to succumb to the damage portion of that. But one thing that all lithium batteries do have in common is that they enter into a state of thermal runaway. Now, thermal runaway, if we go and read some basic definitions of it, it's when lithium ion enters into a state of self-heating or a self-energizing state. So it starts eating its own energy. Okay. So the whole query around this starts happening is what makes it start and how do we stop this in the first place? There's a very famous video of a burning lithium ion electric vehicle that they had to dump in the ocean for it to cool down. So the whole thing is to dissipate this energy. Now, lithium has a very bad thermal runaway in that it has to first eat up all its energy before it'll stop burning. So if you look at a typical pack of lithium ion cells in this video, you'll see that the first cell was put into thermal runaway, and it slowly heats up the next cell, and that cell goes into thermal runaway and dispels its energy, and so it continues in a chain reaction. Okay, so while that is burning, that energy is busy being dissipated, that you've now moved the molecules across the barrier. So it's trying to dissipate this energy. So what happens with thermal runaway is that there's heat generation, temperature rises, and then there's a reaction that occurs. Now that requires some or other initiation event. Now, that initiation event can be a couple of things. We're going to look at those a bit closely now. But the reality is that it's a continuous little cycle that continues going around, in that there's a heat generated, temperature rise in the cell, increased reaction rate, and then it heats up the next cell or heats up the next partition, and continues heating till it reaches a very unstable state. On top of that, there's certain gases and everything that get released when you do have a lithium ion thermal runaway, and these gases create other risks. One of those risks, if we look at the video from the fire research FSRI in America, they put a battery into thermal runaway, and that thermal runaway created enough force to blow a garage door across the road. So the thermal runaway here released flammable gas, and flammable gas collected and became an explosive atmosphere, and that explosive atmosphere formed, and a source of ignition would have caused that to ignite, and it would have driven and found a place to escape and build a bit of pressure, and you've got a bit of an explosion. Now, thermal runaway is typically caused by a couple of various techniques, and thermal runaway variances differ on the makeup of the battery. Our most common type of battery is our lithium iron phosphate, aka LFP, which will go through thermal runaway in a very short bandwidth, between 200 odd degrees to about 250 odd degrees. And it would go into that thermal runaway and burn out its energy and then go away. Now, different makeups of batteries, for example, your NCA type battery, which is the older variation, had a much wider range on thermal runaway, so it would enter thermal runaway and end a lot later, but it would also have a lot more energy to expunge because its energy density is a lot higher than that of lithium iron phosphate. Lithium iron phosphate is seen as a safer type of battery, not only because of its crystal lattice structure, but because of the fact that its energy density is a little bit lower. Its volatility is a little bit lower. It's less susceptible to damage, but it doesn't mean it's 100% safe. There's no such thing as 100% safe. It's just that if it does enter there, it takes a lot for it to reach there. So typical things that happen with thermal runaway is you've got environmental effects. They're installed in a hot environment. They're installed in environments that we often have control over, but don't really see the control over them, where you install it in the British love installing them in roofs. In South Africa, that would be a very, very hot environment for that battery to be in. So you look at your environmental factors. Is it going to get wet? Is it going to get this? Mechanical damage. Now, the most common thing I see is people put it in a garage and a perfect bumper height, which is anywhere up to about 1.2 meters off of the ground. Perfect for a vehicle to drive into. Electrical overcharge. Now, with the current BMS technologies and the current technologies, this is a little bit more difficult to achieve, but it does happen where these are faulty, where you do overcharge a lithium ion battery. Now, older batteries would enter into a state of release, like your old gel types, etc., when they are in overcharge. But because they don't have the strict controls of BMSs, the lithium ion gets limited a little bit better. Now, electrical over discharge. So when you draw too much out of a battery and you put it into a deficit, also not very common given the current controls, but it can happen when you have, for example, an installation that's purely on voltage sensing and so forth. An external short circuit. This is a very common cause. So if there's a short circuit external to the battery or a low voltage that's induced into the battery, causes the BMS to go into short circuit, or shorts out the BMS, and the BMS cannot protect the battery anymore, and then it fails. Same thing that happens when there is an over discharge, is the BMS tends to fail, or BMS shorts out, and then you would run the battery at risk. Okay, design and manufacturing. So if there's a poor design, so a lot of your cheaper types of batteries and your manually manufactured batteries have nuts, bolts, and all of these type of things that you would typically find come loose with age, etc., or they're not tightened correctly, or they're not torqued, spec'd, etc. within realm. They work for just a set time, but they do need to be maintained. A lot of the cheaper batteries do have a bolt and nut configuration when doing their arrangements. Aging of the batteries. Now, this is going to become a little bit more common, and I foresee a few more fires in our industry late coming up, which would basically be around that when lithium reaches around the 5-year mark, the chemical composition does start degrading. And when it starts degrading, it becomes a little bit more volatile, meaning that if you haven't maintained and you haven't done anything correctly, you potentially, given the aging and the volatility of the battery's makeup itself, could wear through that crystal lattice. The graphite barrier might be gone, whichever, and you run more of a risk with an older battery to enter thermal runaway. Now, when thermal runaway occurs in a lithium iron phosphate battery, the FSRI tested this, and they came out that that when a battery goes into thermal runaway, its percentage release of gases released into this out of this process mainly composed of hydrogen at 49% and hydrocarbons and carbon dioxide and carbon monoxide consisting of the other 51%. Now, this puts you in a very interesting sphere, because any person who's been in the hazardous environments know that hydrogen is extremely explosive. Hydrogen percentage per air from LEL to UEL is anywhere from 4 to about 70% volume. Meaning if you've got a 3x3 room, you need a 1 cube meter room, part of that room to have hydrogen in that volume of air in a 27 cube room for it to be explosive, which creates a big risk for secondary explosions. I'm currently doing a lot of drives on this specific topic because, to me, the risk that you have there is brought to light with a lot of the poorer installs, poorer methodology, anything. And normally your battery doesn't create the fire. It's normally a component to the fire. And if it does create a hazardous environment, it is a big risk, because you put it in a garage or you put it in somewhere where there's literally a car with full tank of petrol that's sitting there waiting to expropriate this fire. But the secondary effect is also that it does poison you. Inhaling of these gases can damage your lungs. There has been recent incidents with this, which we're going to look at a bit now. But the reality is, oftentimes, us as electricians, us as technical persons, we're not properly geared to deal with an incident when one of these batteries go into thermal runaway. Okay. So, looking at a current incident in industry, we've got one of these batteries. That's a battery that's currently going into thermal runaway. Incorrect voltage was put over to a cell, and it went into thermal runaway. Now, it was incorrectly wired. It's error, but it did short out the BMS, or the BMS did not function correctly. So, in essence, this electrician who disconnected here ended up being in a coma in a hospital. Then we've got another incident which happened outside Standard Bank, where you had a BES system that went into thermal runaway and just kept burning. You'll see the firefighters aren't correctly trained if you go and look at international specification on how they should be trained. And nobody stands in front of an open door like that while something's busy burning. And they had to expel this thing using a couple of tens and thousand liters. Not only have they tried to use water, which is the worst possible thing, it just cools down the fire. And if what they used in this case, they used about a couple of thousand liters of what is known as fire block. Now it's a gel based. You'll see the green base at the bottom there. It's a gel based deterrent that basically goes and coats the battery and cools it down. So what can be done differently in these instances is what we're looking at. So routine maintenance, adding routine maintenance to it is very, very important. Manufacturer-specific training. Learn to know your product. Learn to know how your product works. Learn to know how you can integrate your product with fire protection. Having integrated fire protection. Quality assurance, making sure that you work to a specific quality level, making sure your crimping is done correctly, making sure all of that's done. When you respond to a fire, make sure you've got the correct PPE. Make sure you have the correct suppression. And lastly, and this kind of points a finger back at all of us that work on the standardization side, is we need to start getting more industry specifications in. This is an example of one of our local assemblies that integrate that fire block that we just saw earlier into one of their battery systems to extinguish batteries that are in thermal runaway. If one of the cells heats up, it'll cool that cell before it goes into the full-on reaction. So if we look at standards, where do we look? Do we look into 10142? Do we look into 10.10.8? Or do we look at the building regulations? Now that's a bit of a conundrum, because at the one moment, if you go read 10142, there's not much in there. And what's coming with edition 3.4 that Andre has already mentioned is that we're adopting more and more standards that are specific to lithium batteries, but we're not making local requirements specific for installation thereof. And that might be a gap that we have on the standard side. Okay, because if you look, 10400 it's not its job to guide us as electricians or as installers or as anything. 10400 has a mandate to define what a building is, and there's currently a lot of opinion around the application of 10400, but 10400 basically just tells you, I have this, I do this. It doesn't go into, I protect against a fire by doing this. It says the burning is burning lasts this long. And that is still a discussion that has to be expunged and extended upon with the relevant authorities in the building side as well. Because nowhere does it specifically cover the battery side. It's currently being interpreted to something which improves safety. I have no problem with that, but there is a problem of connection and a problem that not everybody is applying the same specification. And that's what standardization is. We all apply the same specification. If we look internationally, your Australia, New Zealand, your AS 5139 specifies that batteries, basically a summary of it is here, which summarizes where batteries can and cannot be, under stairways, allow safe exit, all of those type of things. Reasonable things to allow somebody to exit if this thing burns. America also has specific requirements from NFPA 855, where you can store up to specific sizes in specific environments. So are we as South Africa maybe just not lackadaisical about it? But the query that in the drive I have at the moment is industry needs to stand together. All of the different associations need to stand together so that we can get to a point where we can standardize on one requirement. And part of that standardization is also writing it in a formal standard. But before then, we have to get into industry as this is what we want. So us as industry and us as individual need to start calling for more stringent requirements, more straightforward requirements. Let's all start agreeing with something as opposed to just fighting about something. So from my side, I want to leave you with that, in that we need to, as industry, start standing together and start making this a little bit more standard in approach. Most manufacturers would recommend some of the safe recommendations that the Australians and the Americans and all have already adopted. But we as industry do need to start driving this home. And we need to start driving it with users and telling them this is the risk that you face as a user with a specific battery. Thank you. Hope I didn't go too much over time.
Thank you, Anthony, for your extremely valuable and interesting presentation. I've taken a lot out of it in terms, I've got a lot out of it. I've got a lot of insights from it. And I am sure the audience has too, and for leaving us that powerful message at the end, that it's up to us. It's up to us, to start getting our act together and agreeing on certain minimum standards, and then also look further than just minimum standards, but to best practice, not necessarily mandatory, but good practice, codes of good practice. So thank you again for that, Anthony. And we're now going to move on to our next presenter, whom I'm going to introduce to you now while he puts up his presentation and switches on his camera and microphone. And I'm talking about Hein Herold, the CEO of the Herolds Group, a company that started from humble beginnings and now with a national footprint, said to be South Africa's largest importer and distributor of electrical and solar products. These include solar PV modules, inverters, batteries, battery energy storage components and systems for the residential, commercial, and industrial sectors. Hein has an extensive experience in the wholesale and retail industry with a strong background in growth and management. He's recognized as a speaker and expert in his field, actively engaging on industry trends and challenges, particularly in renewable energy and project management. In 2024, Hein was awarded the title CEO of the Year in the Energy Box Solar Energy Storage Future SA 2024 event. So it's great to have you back with us, Hein, and we're looking forward to hearing your insights on this important topic.
Thank you, Chris. Thanks for having me again. And it's always an honor to be invited back. I have a lot of friends that's around the table here. Leon and I have come a long way, and I've dealt with Anthony and the guys, and I really appreciate all the work that they are doing. And I really like the fact that you said that, we as South Africans like to do things ourselves and, sometimes reinvent the wheel. And I think I'm sort of one of the guys that's sitting on both sides of the fence, where I'm a real big advocate for, non-DIY installations, as we are working with very, very sensitive and dangerous equipment, and also having qualified people doing the installations and not just run-of-the-mill. If you look at Australia, an electrician is actually very, very highly paid job in Australia, and that is because they're considering working under much more dangerous conditions than what surgeons are working under. But so like I said, I'm almost on both sides of the fence here, because I do feel that through my presentation, you guys will also see where I sit on certain topics, and what really becomes a bit of a problem when you start over-regulating certain aspects of things and not follow where the whole world has been going. So I think one of the main things is that as solar PV and battery systems continue to grow, media coverage and fire-related incidents has increased in parallel. However, analysis of news reports reveal a consistent pattern. Initial blame is often directed at solar technology itself, while subsequent investigations typically identify alternative causes. Media reports frequently associate fires with solar panels because they are visible on rooftops, represent relatively a new technology, and align with public uncertainty surrounding the energy transition. When building equipped with PV burns, headlines often imply that the panels are the cause even before investigations are completed. And that goes the same for batteries. In reality, findings often show the opposite. A notable example is the fire at Vodacom headquarters in Cape Town, where early reports linked the incident to rooftop solar panels. However, forensic investigations later confirmed that the cause was an electrical fault. This highlights a critical issue. Correlation is often mistaken for causation. Across multiple cases, media narratives tend to follow a predictable pattern. Initial coverage suggests solar panels or batteries caused the fire, often supported by the dramatic imagery of burning rooftops. Later findings identify electrical faults, internal wiring issues, or unrelated causes. In many cases, investigations confirm that the fire originated elsewhere and merely spread to the roof. While media narratives can be misleading, expert analysis are far more consistent. The risk, okay. A research published in the journal Cleaner Production 2024 indicates that solar-related fire incidents are relatively rare and often difficult to quantify due to the inconsistent classification and reporting practices. The study highlights that PV systems are not commonly identified as primary causes and that fire data sets struggling their contribution to the overall incidence is relatively low. Right. Similarly, data analyzed by the Netherlands Organization for Applied Scientific Research found that less than 2% of building fires occurred in properties with solar panels, and only a fraction of those were directly caused by the solar installation itself. This indicates that in most cases, solar systems are present, but not the root cause. When examining battery storage, the picture is even clearer. Industry data from Australia shows that residential battery systems account for only a small percentage, between 1 and 9% of lithium-ion battery fires, with the overwhelming majority originating from consumer electronics such as e-bikes, power tools, and even mobile devices. So the main causes of these incidents across both PV and BES systems constantly is identified as poor installation practices as the leading cause of these incidents. Technical analysis and industry reports highlight factors such as incorrect loose connections, DC arc faults due to poor wiring, substandard components or system design, and inadequate protection systems and improper battery management or ventilation. So the main thing is we first need to look at where the industry is going and what the industry needs to do and how they need to install it, and look after the people doing what they are doing rather than going back to the equipment. So, your webinar asked for talking about things like power optimizer and arc fault detection. So, as a distributor, we've seen all of these things. So, while research confirms that fire risk remains low, industry best practice focuses on proactive risk mitigation through advanced technology, system design, and installation standards. Modern solar storage solutions incorporate multi-layers of protection, ensuring systems are not only efficient, but inherently safe. So while I am a supporter or a big advocate for a modular level power electronics like optimizers, I do believe that they can provide additional yield in shaded conditions. They are often oversold. Modern day AFCI technology is capable of addressing many of the same safety concerns which optimizers did address. So one of the challenges with optimizers is that they introduce an additional component, and that introduces inherently additional connection points into the system, which in turn increases the number of potential points of failure. DC arc faults are widely recognized as a leading cause of PV fire. Modern inverter technologies now actively mitigate these risks. Modern inverter technologies like SIG Energy, Sungro incorporate advanced arc fault detections of up to 600 meters, capable of identifying abnormal electrical signatures and automatically disconnecting the system when the fault is detected. These systems can interrupt circuits within milliseconds, not seconds, preventing ignition before it can even occur. So AFCI detects the arc when it starts happening and then shuts down. Where it's required, rapid shutdown functionality can also be achieved through integrated features or in a combination with module level power electronics. Advanced inverter protection and system intelligence. Modern inverters from manufacturers such as SIG Energy and Sungro function as central safety control systems with key embedded protections. These include overvoltage, overcurrent protection, automatic shutdown during grid failure, advanced thermal management systems, and real-time monitoring and diagnostics. Additionally, intelligent energy management systems, built-in EMS systems, particularly on platforms such as Cygin Cloud, continuously optimize energy flow, detect anomalies, and then trigger proactive responses. So I think one of the main things was in Anthony's video is where the thermal runaway happens. When this is actively monitored with the technology that is available today, you can stop it before it happens. Integrated fire protection and containment. Now, I'm going to share a video just now, but the next generation BES solutions actually incorporated multiple layers of safety design to both prevent incidents and limit their impact. These include advanced battery management systems for continuous temperature and fault monitoring, automatic isolation of affected modules, multi-level protection against overcharge, overheating, and short circuits, all of the culprits that Anthony did speak about. And in certain systems, additional safety features such as integrated fire detection and suppression are also included. These are further strengthen all the overall system resilience. Sungrow's power stack utilizes multi-layered protection strategy to mitigate thermal runaway and electrical risks. Key safety features includes intelligent liquid cooling, advanced cell level monitoring, and integrated fire suppression systems. These capabilities enable early detection of abnormal conditions and help prevent the escalation or spread of fire-related incidents. SIG Energy incorporates a comprehensive multi-layer battery protection architecture, including temperature sensors, internal fire suppression mechanisms, aerogel insulated pads, decompression valves, high temperature resistant insulation materials, and high temperature insulation materials. These features are designed to detect and manage potential faults at an early stage, enhancing overall system safety. In addition to this, also advanced functionalities is anti-backflow, as well as intelligent arc fault detections make these systems inherently safe. So just a video I want to share with you, and this is basically what it comes from. So there's 5 layers of battery safety protection built inside each battery block. So first of all, you have high temperature insulation pads that are attached to the inner walls of the packs. You have an internal fire extinguisher which neutralizes flammable gas in 4 seconds. Aerogel pads, which prevents heat being spread from the one cell to the next, which is one of Anthony's concerns. A decompression valve to let dangerous inner pack gases expand. And then 7 temperature sensors that monitors temperature all across the cells to make sure that thermal runaway does not happen. So to get back to system design and installation, and we go back to the human factor, PV systems are inherently safe under normal operating conditions. And it's only if they are installed and maintained by qualified professionals. And that is where the key lies. They need to be installed and maintained by qualified professionals. The problem is that we do not have enough qualified professionals, number one. And number two, we need to train more qualified professionals for the mass adoption of solar and battery energy storage systems in this country. And I feel that that is more of a roadblock that we are currently having, where becoming a qualified professional takes a very, very long time. So while modern technology incorporates multiple layers of safety, correct system design and professional installation remain critical to overall system performance and risk mitigation. In August 2023, civil engineering Michael van Niekerk highlighted that PV systems are inherently safe, provided that they are installed and maintained by qualified professionals. Maximum safety is achieved when installers adhere and to recognize best practices, systems are correctly sized, specified, and configured, and batteries are appropriately located, installed, and adequately ventilated. Ultimately, even the most advanced technology relies on proper implementation to deliver safe and reliable outcomes. Anthony's video showed, multiple battery runaways. The thing that I find quite shocking is that most of them are the locally assembled batteries, which now we are being forced by ITAC to have a duty on imported products which have all of these advanced safety features, which is again one of the reasons why we are moving backwards as an industry and not forward, because we would rather let the end user pick up the bill than and increase the cost of these systems than looking at a situation where they actually catch up with international standards like the IEC and UL 1945A, 1945A, and all of the other UL regulations that actually has dealt with these things. And I think that is one thing that we as an industry in South Africa needs to get to, where we start, because our first speaker mentioned that they had international funding to get this working group going. SABS then got involved. Then it went backwards again. Where if you look at international standards like IEC and UL, these standards already had the funding behind them. All of the work has already been done. All of those systems are already proven to be safe. Why are we trying to reinvent the wheel and go backwards and want to do it by ourselves with a group of 25 to 40 people when the world has already adopted these in international countries? And get back to what Anthony was saying. Are we lacking South Africa, or do we just want to do things our own way and do it the way that we feel is best because we always know better than what the rest of the world does? The problems we frequently encounter is the incorrect DC PV cabling in solar installations. These remain a frequently discussed issue within the industry. It presents a significant fire safety risk as standard cables are not designed to withstand the high DC voltages, prolonged UV exposure, and temperature fluctuations which PV systems are subjected to. These can result in insulation failure, loose connections, overheating, and ultimately DC arc faults. A proven solution lies in the use of TCC or H1Z2Z2-K cables. These cables are specifically designed in accordance with international standards for PV applications, featuring double insulation, excellent UV and weather resistance, high tolerance to temperature and flames and fire. As a result, they offer reliable long-term performance and reduce the likelihood of electrical faults. Another concern is the use of substandard protection devices. This is a common issue, mainly in many installations, presents a serious yet often overlooked risk. Modern day inverters are equipped with high quality built-in protection that have been rigorously tested and designed to provide effective protection under real world conditions. Unfortunately, there's a widespread misconception being implemented that additional external devices are always required. In many cases, this leads to the poor installation of low quality or incorrectly specified equipment, which do more harm than good. Poor quality equipment may fail catastrophically under surge conditions, potentially increasing this risk of fire rather than reducing it. And that is a very, very, very big concern. On my last portion, which is the conclusion, which overregulation can have unintended consequences which increase the risk of failure. Overregulation is really becoming a big problem. Excessive, poorly applied regulation can lead to situations, particularly in South Africa, where installers and regulators attempt to reinvent the wheel without fully understanding what protections are already integrated or which technologies are inherently safe. This often results in unnecessary addition of components where cost considerations lead to selection of low-quality products. The risk is compounded by the fact that regulation typically specifies the requirement for protection, but not the quality or the standard of the products that are being used. As a result, adding external devices can introduce new points of failure rather than improving safety. There is therefore a clear need to evaluate technologies and their merits, distinguishing between what is genuinely necessary and what is not, rather than applying a one-size-fits-all approach. Research consistently reinforces key industry truth. Most fire risks arise from poor installation practices rather than from the technology itself. Modern technologies not only keep fire risk low, but actively mitigate at multiple levels within the system. As adoption continues to grow, the combination of high-quality equipment and correct installation remain fundamental to delivering safe, reliable, sustainable energy systems. Thank you, Chris. I mean, I can talk about this for days, but we see more where, and the biggest problem is that electrical contractors don't all actually sit there and tie the screw themselves. They have people that are, in a hurry to get a job done. They decide you've got the brilliant protection built into the inverter. that is coming from an international company that has spent millions of R&D on this product. And our regulation decides that we need to cut the cable and let somebody install whatever he feels is good as a safety protection device without specifying what that is. And that then often becomes the burning point. Australia has learned from this. The whole world has learned from this. PV disconnects on the roof has been outlawed in Australia, where they actually started the same way that we did. And now we have a situation where we are adding more potential points of failure, where the actual devices that we are buying have been equipped with them. And that's just basically where I want to finish up with, is rather than looking at writing code on adding external devices that leaves it open for a user to go choose what it is, either go specify what the product is he needs to use, or rather look at the inverters and only approve the products that have these safety features built in, and say that, well, to protect South Africans, let's only approve inverters that are inherently safe, that we don't have to go reinvent the wheel and add a bunch of extra failure points to make sure that it's safe at the end of the day. Thank you very much.
Thank you, Hein. Thank you very much for those insights. You make some very powerful points about modern practices by OEMs that have spent a lot of time and effort in creating safety features that are just unknown by installers or local people that write standards, sometimes reinventing the wheel. I think the SABS is moving in the right direction by looking at adopting IEC standards that are well proven, and I think is aligned with your thinking in this regard. So thanks for those insights. We are running behind time, ladies and gentlemen. I'm going to call a 10-minute comfort break now, or shall we say a 9-minute comfort break until 3:15. 3:15. It's now 3:06, 6 minutes past. So it's a 9-minute comfort break. If I can please ask you to be back at 3:15 when we will resume this webinar. It's been a fascinating webinar so far, with some really serious insights from industry experts, and there's more to come. Some significantly more information from OEMs and practitioners who are involved in rolling out a widespread and significant family of installations across residential and solar PV. And we're going to listen with great interest to their experience and insights, which I think add enormous value to the knowledge of the risks that are faced, fire risks, installation risks, product risks, and ultimately, how do we mitigate these risks through installation practices, through latest technologies, and through systematic and proactive design to make products inherently safe, so that even if there are external installation problems, even if a car does drive into a battery, one can still have safety practices built into the design that make catastrophic failures either virtually impossible or dramatically reduce the risk. I hope the insurance industry is listening hard to what is being said today, because ultimately they pick up a lot of these risks and are there to cover and insure against these risks, and they can, by listening hard to what is being said, mitigate their own risks and improve their own financial performance by proactively adopting best practices requirements for companies and systems that they insure. So yeah, a fascinating talk. Enjoy your comfort break, stretch your legs, and please be back by 3:15. Thank you. Good afternoon, colleagues, and welcome back after the comfort break, which I hope you have had a chance to stretch your legs and are ready for our second half of this webinar. It's really been a most interesting and valuable webinar to date, and there's more to come. And it's now my privilege and pleasure to introduce our next presenter, which is Patrick Narbel. And Patrick has a PhD in management science and a dual MSc degrees focusing on energy and international management. Starting in academia, Patrick transitioned to management consulting, and he spent over a decade advising utilities, regulators, and governments across Europe on energy policies and tariffs. As a principal consultant at Avery in Norway, he focused on regulatory and technological developments in distribution and transmission networks. Patrick is the Chief Technical Officer and co-founder of Go Solar, where he drives innovation by selecting components and products that maximize system efficiency and ensure top quality services. I think you probably know Go Solar is a leader in South Africa in the field of rented solar PV and battery energy storage solutions in the residential and commercial space. He'll no doubt tell us more about the company and its activities. He is the chairperson of the Residential PV Work Group at SAPVIA, the South African Photovoltaic Industry Association, where he plays a key role in shaping industry standards. So it's a great pleasure now to hand over to Patrick. We're looking forward to hearing your presentation, Patrick.
Thank you, Chris. Thank you for the introduction. So indeed, I work at Go Solar. We started the subscription idea a few years back. The industry caught on. Now we're managing tens of thousands of installation. And then obviously fire risk and safety is at the core, because our customers, we want to keep them over 10, 20 years. So we need to make sure that what we do leads to high quality install. What I want to do today is to build on what my esteemed colleagues have been talking about. And I will touch on a few of their points, and hopefully it can bring some new angles to the discussion. Solar hybrid systems are seen as generally safe, and incidents are very rare. The biggest fire risks are, however, linked to poor installation and neglected maintenance. So I'm going to bring in the concept of maintenance that goes over what has been said, and then cover some points related to regulation, as well as installation quality, selection of components, and the way they have evolved over time. The picture I have here, which is obviously a dramatic situation of what could be, is a good summary of what could go wrong. We have components, they can be subpar, they can be high quality, they will age, but if the installation isn't done right, if we're not doing maintenance regularly, you might have some damage that will evolve into something, either the product not working or can evolve in a fire. We could have issues with the wiring, which can lead to people getting shocked, etc. So that's kind of what I want to talk about today. So mostly focusing on the install side of the installation and how we can minimize hazard. So a lot of the answer on how to minimize hazard is by selecting quality components. We heard about that from Harold. It's about choosing certified installers. It's people that have the right qualification, that have the right experience, that have been exposed to the solar industry for long enough to know how to do it and to make it safe. Those certified installers, they may need to be in tune with the latest regulations and evolution to make sure that we always comply to the latest that is out there, and hopefully can follow the international best practice as well. And then, as I mentioned, having regular inspection on sites will contribute to reducing those hazards. So we'll be talking about regulations, tech, and people. When it comes to regulations, I was humbled by the people that are presenting today. So I'm not going to try to compete with them and tell you what they work with, but I just wanted to bring in some example, which I think are going to assist in the discussion we have today. This is also something that we are very busy with at SAPVIA, where I have the privilege to chair the Resi PV group, and we're busy developing a FAQ of the common risks seen on solar installation, and we're going to start making them available to the public to drive awareness and ensure that installation is of high quality. Why do we care so much? It's very simple. That also speaks to some of what Hein was talking about. We are all connected in a way. Whenever there's a fire and the house burns down, we are all impacted. All of us would have noticed a drop in sales when the Vodacom fire happened. The fact that it wasn't linked to solar components, it was largely irrelevant. The mere fact that it was suggested that it was due to the solar components was sufficient to impact us. So we all benefit from making sure that every single one of us, from the manufacturer and designing high quality products to installers in doing good installation and proper maintenance, ensure that the qualities of the install is of high quality. But enough about that. Let me talk about one which is always at the core, so the certificate of compliance. The first speaker talked about it today, but this is regulated in different areas. We have the occupational health and safety that touch on the CUC, the electrical installation regulations. We have the SA national standard that are there. And you see it in many places. And at the end of the day, and although it's strange that it seems to be a gray zone, it's fairly straightforward. You don't have the original CUC, you're not allowed to proceed with the install. So you need to have a certificate of compliance before the system is connected to the electricity supply, and it needs to be accompanied by the test report. If you do a solar install, you can then issue a supplementary CUC with the necessary test and refer to the original CUC. If you don't do this, your supplementary CUC is invalid, and it shows that you haven't done the due diligence in assuring that the property is up to code. Obviously, a CUC can only be issued if the work done was in line with current regulations and carried out under the general control of the person issuing the certificate of compliance. So it's about having the right people in the right place doing the right test to make sure that it's done right. And the one that is perhaps the most important is the last one. There's no way to contract out of the CUC obligation. There's not a world where you go to a site and you tell the customer that they can sign a waiver for you so you can install and not worry about this. That doesn't work. So regulations are important. We shouldn't over-regulate, but we need to have a minimum set of regulations. And if we don't have them, then we might be doing the wrong thing. So we're supportive of regulations that contribute to a safer environment without over-regulating and being in environments where you have regulations that prevent new technology from evolving and solving those issues that the regulation try to prevent. When we talk about tech, well, we can talk about two things. We can start with the components. Batteries are rare but serious. We have all seen, obviously in this forum, we have seen the original videos earlier in this seminar, but we have all seen videos of people's phone catching fire, or electric vehicle, or a battery, or something like this. So this is the thermal runaway that we were talking about earlier today. The good news is that the technology is evolving. We see the lithium iron phosphate batteries becoming the norm. There are new technologies that could be better and safer than this that will be developed over time. Let's see where we go. But those are better because the thermal runaway happen at a higher temperature, and they don't tend to produce as much oxygen that would fuel the fire as you would have in some of the older batteries. So new technology comes to help. We see that batteries are more and more coming with fire extinguishing systems. It used to be the norm in the commercial space. We start seeing it in the residential space as well, which is great. We see improved IP ratings. Some of the older batteries are rated IP20, which is not offering much protection against water ingress. The new one are IP65 or 66 in some instances, which means that you're less at risk of water seeping inside the battery and then either interfering with the BMS and worst case creating some corrosion or short circuit in the battery, which can lead to thermal runaway. A battery needs to be installed properly. You need to use breaker fuses when needed. We see that the new models are coming with their own DC breakers, giving additional layers of safety. So if you do all of this, it's going to reduce the risk of safety due to the components. And obviously we have the location. We talked about not putting them in an attic. There are other places which are not suitable for batteries, and then we need to touch on this. I'll touch on that in a second again. But again, we mustn't forget about the people side of things. Manufacturers, when they release components, it comes with a document, an installation manual. And if we look at this, it's quite standard that you need to have space between the inverter and the ceiling, inverter and the batteries, on the side of the inverter or in front of it. And this is to make sure that heat dissipation is not impaired and that you don't create a risk of having a roof catching fire because the inverter is too close to the roof or too close to flammable material. Inverters are getting better. We're talking about automatic arc detection and automatic shutdown when it happens to prevent fire risk. So it's great to see that this is happening, and really the incentives are aligned. If you use inverters that have a tendency to catch fire, then the manufacturer is going to lose out, the installer is going to lose out, the customer is going to lose out. So everybody loses out. So there's really incentives from all sides to make sure that those components are robust, they last long, and they don't cause issues over time. When it comes to install quality and reducing risk, people are essential. We, in our years, doing our installs ourselves or taking over installs from other companies, doing the maintenance of other companies' install, we have seen that there's variation in the quality of the install. And we don't want this. So at GoSolar, we started working on a book, which is called the GoSolar Install Standard and Best Practices. And we update it on a monthly basis and try to make it more and more comprehensive. So it's becoming quite a long document at the moment. But if we summarize it, what we try to do is to make sure that each install is clean, symmetrical, it should be the same everywhere, correctly protected, correctly earthed, logically laid out, fully tested, compliant, and boringly reliable. Whether another product is very exciting, but it needs to be boringly reliable in that it needs to be installed properly the first time. And then you do come to monitor every now and then at regular intervals, but you don't have issues where you keep returning it to. This destroys the patients and the customer side and puts the customer at risk, which we don't want to do. So I'm not going to cover all the documents, but I just wanted to take some example of what we work on, how the industry is working on, because a lot of this feeds into the process we have at Sapia. So when we talk about install locations, well, in the regulations, there are clear no-nos. We will never install in the bathroom, in the wet room, for example. If you can't have plugs, why would you have a solar installation? And I can tell you that we have seen some of those in the industry. So that's a clear no-no. And there are some clear yeses. So you want to have it in the garage. So we heard that obviously you don't want to drive into it, which can damage it. And again, there are solutions in Dubai where we operate as well. We put so similar to a buffalo bar. That means that if the car drives into it, they will hit the bar and not the component. But there are storerooms, there are dedicated rooms that are well suited to this. And then in the regulation, there's some maybes, there's some gap. And what we try to do there is to come up with a clear guidelines, often adopting conservative view. For example, you don't install in a bedroom ever, but it would be easy to say that a bedroom is not a bedroom, but a storeroom and it's not used. Well, it might be used in the future, so no, you can't do that. That's kind of what we're trying to do with the installers to avoid risk today, but also in 2, 5, 10 years down the line. So we're trying to be clear where regulations are falling short. And then it's easy to talk about components, about qualifications, about using the right material, but you can't succeed without using the right tools. And this is often an aspect that's overlooked. I'm showing two here at the moment. The first one, the yellow one, is a tool used for crimping battery cables. You want to make sure that it's done properly with the right tension across all the cable to avoid loose connection, future short circuits, or anything that can lead to a fire and then make the battery catch fire down the line. The one in the middle is used for crimping MC4s. MC4s, they are used to link DC cables from the inverter to the panels or from the going into the inverter. And again, if you use pliers, you might do it wrong. The tension might be wrong, and you have something that's loose, etc., which might lead to the type of issues you have on the picture on your screen, where the MC4 heated up and started melting. This is not too much of an issue in the sense that you can go and fix it, but it can quickly become an issue if it's not corrected, if it's not done right. And you want to avoid having to go to correct it. You want to do it right. So to succeed, we need a number of things. We need the right components. We need the right people to do the installation, and then the right correctly dimensions, cables, breakers, fuse, etc., as well as the right tools being used on site. And if you do that, you can mitigate the risk as well. So with those approach, you can really impact the original install. Now, once the install is done, it doesn't mean that you're done with the work. Regular maintenance is important, and I just want to show you a couple of pictures to show what it is. The picture on with the roof, with the impact there, is one of our install in Plettenberg Bay. This has nothing to do with hail. Those are golf ball. The house is not in line with where people play. Apparently, people in Platt have issues shooting straight, but a lot of them have ended up on the roof. The user is a fairly small user, so our systems cannot detect that the performance has dropped as a result of those. So unless you do regular maintenance, you might not notice them. And if you don't notice them over time, you might have water that seeps in that will damage the panel. Best case is that they stop working. Worst case is that you have, again, a short circuit or something else which will cause a fire. And if you have the 8 panels and you can see that 3 of them are damaged, the likelihood that the other haven't been hit by golf ball is fairly low. So what you need to do is a proper inspection to see if there are micro cracks. And you can see if some of them go through or not, and then change them before it's too late. So maintenance is important. And in a case like this, finding a way to prevent those golf balls from hitting the panels to start with. We equipped all our teams with thermal cameras. So when you do maintenance, you go and you obviously see everything. Thermal cameras are used for panels to discover hotspots or dead zone. You also use them to monitor the AC-DC combiner box or any connection anywhere in the system to see if anything is dead or is overheating, etc. We have seen in some instances where you finish the installation and when you come back, somebody else has worked on the installation, and then you want to be able to detect that as quickly as possible. Failure to do so will lead to a risk for the customer, which we absolutely want to prevent. So this is a short intro into a lot of different topics, and I want to close the circle by going back to where we started. But solar systems are generally safe and incidents are fairly rare. International statistics, there's very little statistics in South Africa, but if we look overseas, there are very few incidents and most of them are linked to installation quality. So there's no difference. There's no reason to believe it's different here. The biggest fire risks are really linked to poor installation or neglected maintenance. Those can be minimized by selecting quality components, using certified installers, or having regular inspection in D. So thank you for giving me the opportunity to comment on this very important topic. Back to you, Chris.
Thank you really very much indeed, Patrick. A company that has got experience across thousands of residential and commercial installations. Obviously one has to listen carefully to these kind of people because they have got this fleet that they manage and they are responsible for, and they have to maintain it as part of their contracts. So their knowledge and insights are of particular relevance as a company that actually manages a fleet of thousands and thousands of such installations. So thank you, Patrick, for those insights. And it's a great pleasure now to introduce our last main speaker before we do the wrap up. And that is Shane Marcelo Prince, who is from Huawei Digital Power, another company that is a global leader, technology leader in inverters and battery energy storage systems. Shane has more than 25 years experience in the energy industry, spanning the electricity, oil, and gas sectors. His early career was at Eskom, where in various roles in the power system planning, operations, and project development, he was deeply involved. He moved then to the oil and gas sector with Saudi Aramco, followed then by a stint at Sasol. And from 2020, Shane led the new power generation and IPP program at the City of Cape Town, followed by a role as the head program management at the IPP office. He's currently employed as Chief Solution Architect of Huawei Digital Power Sub-Saharan Africa region. Shane holds a BSc in Electrical Engineering from the University of Cape Town and a master's degree in Business Leadership from the UNISA School of Business Leadership, and he's a registered professional engineer. So a person with deep experience in a wide range of sectors, leading to his current position as Chief Systems Architect, Solutions Architect at Huawei, who, as I say, are a global leader in this kind of technology. So over to you, Shane. We're looking forward to hearing from you. Thanks.
Thank you, Chris. I trust that my voice is clear and that my presentation is up on the screen. I felt it a good idea just to build on what the other presenters have already covered. I'll do my best not to repeat too much of it because they have touched on quite a few of the items that I wish to traverse in terms of my presentation today. So maybe just starting off by understanding why safety is becoming increasingly more important, specifically in C&I applications. And I mean, also some of the other presenters have noted that these incidents are quite rare. However, as we see an increase in the move towards solar PV together with battery storage installations across the world, you may find that there's an increase in these incidents as well, especially if we do not take care and properly manage some of the elements that contribute towards safety not being adhered to. So typically you'll find that these installations are in typically more denser populated areas compared to, say, for example, a utility battery storage installation. Some critical facilities can be affected, hospitals, critical warehouses, etc., as well as some precision manufacturing facilities. And we've seen this, as I said before, globally over the past number of years. The intent, of course, is to get a clearer focus on how do we manage this specific issue going forward, globally as well as South Africa, of course. What we have found, in terms of past research, is that where incidents do take place, noting that they are quite rare, but when they do take place, they are mostly related to issues on the DC side of installations, where we find typically a PV to ground problem, and also quite a high PV current or inrush current issue. And that relates to the higher energy density we've seen within the power plants that have been implemented, in this case solar PV, with of course much higher energy density as well as a higher likelihood of DC faults. And this is due to various reasons as shown on the screen there. Few electronic components, the length of the cable making it vulnerable to external interference, and of course maybe as we go forward, much better understanding of some of the elements that we have to take into account as we develop these safety standards. Improving the DC safety standard has become a global trend, as is depicted here. What's important from our side is to note that South Africa has to follow suit, and I'm quite encouraged by most of the other speakers that have alluded to the move towards exactly this within the South African context. What we're depicting here is the evolution of DC safety solutions over the past 2 to 3 decades, culminating in what we now call system-level safety, where attention is paid to both to elements on the module side, on the cable side, as well as on the device side. And I will touch on 1 or 2 of these items as we look towards some of the suggestions coming from Huawei in terms of how the industry can move forward in improving all of these elements from a safety perspective, both safety of the equipment as well as, of course, importantly, personnel. So the first suggestion we want to look at is the rapid shutdown requirement. And I know that I think Hein has touched on this before, where we do have certain issues around the inability to have the disconnection of high voltage between PV modules, especially, of course, during irradiated periods, where we can then move towards a rapid shutdown facility that will ensure that outside of the array boundary, we have voltage levels that are conducive for the health of humans, and will facilitate, for example, if there's a firefighting incident or the need for firefighters to access certain areas, that they can be done safely without compromising the ability to actually save lives. Secondly, we are suggesting using string level disconnect solutions. So typically you would have the DC isolator being employed to isolate the PV side during fault events. However, This DC isolator is typically manually switched off, making it non-optimal for fast disconnection during events. What is being proposed is the use of an inverter controller as well as a fast cutoff switch that can be deployed within milliseconds, thereby enhancing safety not only of the device, but of course, typically for human interaction as well. Thirdly, we are proposing adopting DC-to-ground protection using the inverter. Typically, you would have insulation protection only during installation. However, after being connected to the grid, insulation impedance changes are typically not detectable easily due to the inverse current being able to impact the AC bridge as well as the DC bus bar directly, causing device damage. What we are proposing is the upgrading of the inverter hardware with DC-to-ground protection that will limit the inrush current and thereby protecting the modules as well as the AC bus bars. Fourthly, we are looking at adding connected temperature detection solution on the DC side of the inverter using negative temperature coefficient sensor connected to the inverter that will easily pick up the over temperature events or conditions, primarily due to, again, coming back to the issue of proper installation and using correct wiring protocols as well as tools, where you would have, for example, terminals not properly connected, not proper crimping being done, as well as some of the contacts being poor due to external forces. Moving over to C&I battery storage facilities, again, the colleagues have touched on this in depth. I'm not going to spend too much time on this. However, just to note that similar to solar PV, on the battery storage facility side, there has been multiple safety incidents occurring worldwide with quite significant damage done to both property and, of course, also posing significant risk to lives. Again, from our perspective, making a suggestion in terms of explosion relief, we have seen various incidents across the globe where not only there has been device destruction, but also damage to property, as well as either people being injured or regrettably even some fatalities during some explosion events. What we are proposing is that we have pressure relief devices on battery storage facilities with explosion vent panels on top that opens up to the top, as well as significantly 5-point door locks on the doors that will prevent the explosion and the gas being in or exiting the container at the front, thereby protecting nearby operators. Lastly, a suggestion from our side is to look at battery storage with automatic SOC calibration. Typically, you would have manual site visits by professionals at a very costly exercise, leading to loss of benefits. For example, taking a few days in terms of complete the manual calibration, as well as certain safety risks that are introduced by the personnel being on site. Using automatic SOC calibration, we get higher precision, of course, lower cost due to no need for professionals to go on site. You can optimize the online calibration as well as operation of the facility. And of course, you also then lower the safety risk due to no external charger being required and avoiding battery packs and cables being removed and installed repeatedly. Chris, that's the end of my very quick overview. I'll hand back to you.
Thank you very much, Shane. And again, it was an absolute privilege to hear from a global technology leader, the insights and really practical recommendations that you've provided, Shane, as to how one can make a significant impact to improve safety. As I think also Hein pointed out, there are, of course, installation risks. There are, of course, things about loose connections. There are the right tools that have to be used. And of course, there's going to be human error. And of course, there are going to be times when things have not been installed properly. But even in those cases, correct system design, product design can make a dramatic improvement in the risks that would otherwise exist, in the case of these external faults. And I have no doubt, that the R&D and efforts of technology leaders globally are making a massive contribution to making these products as safe as is humanly possible. So thank you, Shane, for that. And it's now my privilege to move on to our last speaker, who's going to wrap up, provide some of his own insights based on his experience, as a safety professional and as a member of the SABS 10142-1 work group, and that is Leon Ruiz. Leon Ruiz is a master installation electrician and a technical specialist in electrical installations, compliance, and standards. He serves as South Africa's ambassador to IEC Technical Committee 64 and FSEC Technical Committee 64, contributing to the development and alignment of international standards. As co-chair of the FSEC E-Mobility Technical Committee, he plays a key role in shaping industry direction. Leon is actively involved in SABS standardization work, driving adoption of the IEC 60364 series. He advises on regulatory compliance, safety, and risk, and is known for his direct, standards-based approach to resolving complex electrical and photovoltaic installation challenges across residential, commercial, and industrial environments. So I can think of nobody better to do this wrap-up than Leon. And if I can ask you, Leon, to switch on your camera, which you've just done. Thank you for that. And over to you for your wrap-up and insights. Thank you.
Thank you. Just doing a quick mic check. All good. Thank you, Chris.
100%.
Thank you. Thank you for the great introduction, and I want to thank all the previous speakers. I think we are a little bit smarter than we were yesterday. So we've covered a lot of ground today, from module level optimization all the way through to battery safety and fire suppression. My role here is to bring it together and not to repeat what has been said, but connect the key themes. What stands out is that safety is no longer tied to a single component. It is a system outcome. And that system is only ever as good as how well everything works together. If you step back and look at all the technologies discussed, whether it's power optimizers or fault detection, battery monitoring, or placement, they're all addressing different parts of the same problem. They contribute to detection, control, isolation, and ultimately mitigation of risk. No single device makes a system safe on its own. It's the combination and layering of these protections that changes the overall risk profile. In practice, when systems fails, it's very rarely because the technology isn't available. More often it comes down to poor connections, a misunderstanding of how DC systems behave, or a lack of proper coordination between the components. At times, decisions are made based on opinion rather than a full understanding of the system. And that's where risk starts to develop, often quietly. So the real issue is not the equipment itself, but the decisions behind how it is applied. Every installation is influenced by three key stages: design, installation, and verification. Design sets the intent, installation determines what is actually built, and verification checks that it meets a minimum level of compliance. Excuse me. The challenge is that these three don't always align. A system can meet compliance requirements and still have coordination gaps. Those gaps are often where problems begin. Looking forward, the industry needs to continue improving how it approaches these systems, and that includes stronger alignment with recognized standards, a better understanding of DC-specific risks, and a shift toward thinking about the system as a whole rather than individual components. Industry discussions is important, but it needs to be earthed in both standards and real-world application. Ultimately, accountability sits with those making the decisions and signing off on the work. If we simplify everything together, PV and battery systems introduce electrical, thermal, and fire risk, all interacting with one installation. Incidents are almost never the result of a single failure, but rather a chain of smaller issues. The goal is not just to install systems, but to understand how they behave, especially under fault conditions. If that behavior isn't properly understood, the system isn't fully under control. This is just a contact card of mine, and I thank you for all the speakers again, and thank you, Chris, for inviting me. It is a massive, massive opportunity. Thank you.
And thank you to you, Leon. You've actually brought us back into time and given us a succinct, wrap up and summary that we can take away. And you've given us a presentation which I'm sure is going to be studied carefully by the audience, by people that have attended today, as well as by people that were not able to attend today but registered to attend. They will, of course, get all the presentations and the video recording of today's events. And I would just like to conclude and thank you most sincerely again for agreeing to do this wrap-up. We've had a number of interactions, very valuable interactions over the regulatory compliance processes of municipalities and Eskom, and I've always found your input critical and thought-based, evidence-based as well. So great to have you on the presentation or on the webinar to do this important wrap-up. So colleagues, we're now going to move on to the Q&A session, and I've got 30 minutes set aside to answer just some of your questions, but I'm just looking at the Q&A text facility on Zoom, and I can see that we've had about 50 questions approximately, of which 45 questions have been answered already in text form by our presenters. So I'd like to thank our presenters very much for helping me. There's no way that I can get through 50 questions on a webinar like this. So our presenters have really helped with their expert input in answering these questions. But I've been keeping an eye on the questions and trying to identify some common themes. And I'd like to ask now all our presenters to please switch on your microphones and switch on your cameras so we can see you. I'm going to
Chris, one of the things is we don't have the ability to ask questions. Presenter.
Look, you do. I'm certainly going to give you
couldn't
that
type
opportunity.
A question. I could actually.
Why don't you start? You start with the first question.
So I have a question based on the model where you have subcontractors that are doing the installation, and I believe that the liability still lies with the person issuing the COC, right? And not because we've entered, and especially in the Go Solar model, for argument's sake, a situation where you've got a company that generates the sales of the subscription model or the sale of the solar PV system, even if it's not on a subscription model or PPA. You've got a lot of companies providing PPAs that are, they sell the PPA, but then somebody does the installation on their behalf. The liability as it stands now, and I stand to be corrected, lies with the installation contractor at the end of the day, the one who issued the COC. The inherent problem that I see, and this tends to go back to the subpar equipment, and although I am very much a fan of selling excess equipment, seeing as I'm a distributor, like external fuses, external DC protection switchgear, external combiner boxes, and all of that, they all contribute towards my revenue. The problem is when you are running this low cost model, you end up with, for lack of a better word, just sharing this image, where you have a complete mixed smarty box with wires crimped like this, it's a real bad situation. And this is mainly because there is so much pressure on the pricing of this installation when it needs to happen. Does that still lie with and I think this question is actually towards Anthony and Andre, our first presenter, is there any mechanism where this transfers towards, the original originator of the installation, or will it always still remain with the installer or the person that issued the COC? Because I have seen a lot of people with papers to issue COCs that cannot do an installation and has got absolutely no clue how to do a quality installation. And then I've also seen a lot of people that have not been able to get qualified because of funds or whatever it is, but understands way more and can do a way better installation than what a qualified person can do. So where does this transfer?
Yeah. Now, let's put this firstly to Anthony and then to Andre and maybe even to Patrick.
Yes.
And Anthony, does the buck stop with the guy who signed the COC? Now, obviously, the guy who signed the COC doesn't necessarily actually do the work, but he's got to check the work and he's got to sign it off. And is he where the buck stops in terms of liability, even in installations where a company like Go Solar has got a whole fleet? Does the person who signed off bear the legal liability?
Okay, so very important to understand, and if you look at it specifically in Go Solar's nature, there's in effect two pieces of legislation involved with Go Solar's model. And that would be a contractual agreement where they still own the supply, they still own a piece of the premises. So they in essence still have a contractual responsibility towards the specific components. They still have a right over specific components, but the penultimate safety thing does sit with the guy who issues the COC. And that does create an inherent issue because paperwork doesn't always automatically make you competent. Your skills, your workmanship, your everything is what technically is defined as competence in the electrical contractor construction regulations. It's not only about the paperwork, it's all about your experience, it's all about everything else. So specifically with what Ryan has now mentioned is, does the buck stop with the registered person? As far as safety is concerned, yes. As far as the contractual obligation goes, there is leeway. And that is between the signed agreement between the user and the person who still owns the equipment. So there is a little bit of complexity around this if you take it to that level. But when it comes to safety, the buck stops with the registered person.
Yeah. Let's put this now to Patrick. Patrick, you've heard what's been said, and I'm interested to hear your input, on this particular issue.
So I'd begin to turn it around and look at it from the customer perspective. They enter the contract with us. So if something goes wrong, if it's the fault of the installer or our fault, it doesn't really matter. They'll talk to us. So we need to do what's right for the customer at the end of the day, regardless of where the liability lies.
Mm-hmm. Yeah, very good point. You actually appoint the installer, and it's your design, and ultimately, therefore, I would think that ultimately you take responsibility. But yeah, interesting points about liability. Andre, I don't know if there's anything you want to add to that. If not, no problem. But if you want to add anything, please come in.
Thank you, Chris. Am I audible?
Yes.
Okay. Chris, firstly, I think we must firstly have a positive approach. So I think the glass must be more full than empty, half full and not half empty. And sorry for this, but I think a monument must be built for our contracting industry who provided us with 7-point-whatever gigawatt solar. It came with suppliers like Hein, others. It came with a lot of criticism. uncalled for sometimes, but I think without knowing, we have not done the worst. We done a good job, and we are
We
not
did really well.
congratulating. We are not congratulating ourselves. I would build a monument. If I was Eskom, I would finance it for the industry. So that's just a mind shift. But I think, and there I want to get to what Hein is also saying. It's a leadership issue. We all in a system, the SABS and the suppliers, the standard writers, the electrical associations and so on, and I feel the synergy between the let's call it the building blocks are not really the whole time getting the best out of us as a country. We are lucky, I think, to have a very low incidence of let's call it tragic events. But the buck must stop. Firstly, legally, it must stop with the person signing the COC. But I think the regulator, if I may call on our side, on the installation side, being the Department of Labor, and their agents must also play a role in ensuring, even by spot checks, that we do the right things. I think training is too voluntary at this moment. It must be given more emphasis. O&M systems. I mean, we don't write about O&M operations and maintenance in standards. It's a practical thing. It comes from within the industry, the suppliers, etc. Test reports. We get criticized about test reports, but Satvia and other people, they got test reports. Okay, I know the chief inspector must say he's happy with it, but we are allowed to think outside the box as well and have a test report suitable if we are an organization serving our needs. So in short, I think more leadership. And there's not one big leader, but between the role players, they can display more leadership, I think, and by no ways the person signing off the COC is going to get mitigated in terms of his responsibilities. And they, the ECA and those guys and the AIAs, they must play their role. So I think we're not that bad off. But I think we can do a bit better. But as I say, leadership. I don't know if it helps, but if everyone in the box here does the best they can, we are moving forward. Thank you.
Thanks, Andre. I'd like to now put a question to Shane, if I may, and also possibly to Leon, if he wants to come in, and that is this. I think a lot has been said, and I agree entirely. The incidence of failures and accidents and fatalities on residential and commercial solar PV installations in South Africa is actually very low. And that's not saying that there are installations that are not properly installed. There are plenty, I'm sure, that are not properly installed. But actually, the incidence of fatalities and electrical accidents on solar PV systems is remarkably low. In fact, an Eskom key executive told me recently that they have not had one fatality on a residential solar PV installation in South Africa. And there are something like 40,000 such installations in the low voltage on Eskom's network alone, let alone municipal networks. So my question really is this. I get involved in doing investigations, for court litigation in terms of electrical accidents. And I go around the country, all over, doing these investigations and reports. And I can tell you that not one of them has been an accident involving a burning or whatever, a limb or whatever. Not one of them has been anything to do with solar PV and battery storage. And every single one of them actually have got to do with the electrical distribution networks. 95% of them are to do with informal settlements and illegal connections where the standards of installation are just mind-boggling. They are non-existent. You'll just see wires running across the ground, etc., etc. So my question, and Shane, I'm putting this to you because you've been involved at Eskom, you've been involved in the municipal network. Are municipalities and Eskom not focusing on the wrong problem. I see their intervention about compliance and safety. They make such a big thing about solar PV safety. And yes, of course, we've got to look at safety. But should we not be looking at the beam in their eye rather than focusing on the splinter in somebody else's eye? Because on their own networks, their distribution networks, and the illegal connections to their own distribution networks, that's where the real accidents are happening on a daily basis. Deaths, burnings, loss of limbs. This is where the problem lies. And I tend to think that they're focusing their efforts on the wrong problems for commercial reasons. And I'm interested to hear what you have to say, Shane. Are you there, Shane? Okay, look, I think Shane has dropped
Shane
off.
said that he needed to drop off at 4 at a hard stop. I'm sorry, Chris.
Okay, look, no problem. Let us now put this to. Shall we start off with Andre? Andre, are we focusing on the wrong problem when it comes to safety? I mean, I know there are safety issues that have to be dealt with, but surely we should be dealing with the real problems first.
Chris, yes, I was trying to see the positive side of the good things instead of over-regulating. It was said today a few times. We must be very careful. We're very fond of over-regulating, but we must also have a bit of space for some, let's call it crossbreed. When Eskom, for example, say that they want to ensure that inverters complies with 62109-1 and 2. I think one must give them the benefit of the doubt that they are aware that the standard, which is a correct standard for inverters, are not compliant with all inverters that comes in. But on the other hand, if I may use it, you also mentioned the low incidence of failure. So I think a bit more passion, a bit more, ons moet mekaar verdra a bit, but we must focus on being positive and getting our industry going forward. And instead of doing a lot of paperwork, I think training and the institutions like Xavier and the ECA, the ECB, and all those guys that does training of their members, 10 out of 10 for them. That's all I say.
Leon, please, can you also come in here? I'm interested in your insights on the matter. Are we dealing with the right problem, the most important problem first?
Well, I think solar installations inherently are mostly safe type of installations. And although I've probably inspected close to 1,000 installations, solar installations, and most of them are completely non-compliant. Where there were incidents, the incidents were on the electrical installation and not on the PV installation. So even though non-compliant installations are evident, it doesn't mean that it is necessarily very unsafe. I think we need to also look at that type of problem that we have, is that the houses where installations are done does not comply. And we need to ensure that the houses comply first before a PV installation is done, because then it will just cost so much more to fix.
Yeah, thanks. Yeah, and I'm going to get to you, Anthony and Hein, on this. But you can drive down a street, near Honeydew or whatever, and you can see illegal connections coming off streetlight poles in front of your very eyes. Really dangerous situations that are clearly visible to the electricity distributor in front of their eyes every single day. You don't have to go into a private house behind the meter to find these things, and people are dying and losing limbs on this result. But that doesn't seem to be where the focus is.
No, the focus is not there at all.
I wonder why. Yeah, over to you.
I think one of the main things is the focus generally goes to where the revenue comes from. When they can add on additional regulations and requirements to register your PV system and incur all of these costs when they do not clean up in their own backyard. I think regulation should start at the top. I think Eskom as the electricity provider needs to get the municipalities to get their act together with all of these illegal connections, and the Department of Labor needs to focus there rather than coming at the ones that are actually making a difference in self-sustainability. That's definitely something that needs to happen. However, we've seen a lot of things where it's all about this grand plan, right? But there's no execution on the plan at the end of the day. And that's unfortunately where we live. And I just think that as an industry where we are all sitting together trying to make it better, we should not go down that route of the grand plan. I mean, this is our 10-year anniversary in the renewable energy sector. I have seen many technologies come in and go out. And what I can tell you is that, we've had very little, like Andre says, the document is a live document. The SANS document is supposed to be a live document. The thing is that when a product enters the market 10 years ago or 5 years ago, and people are installing it, what our working groups are looking at is what is wrong, what needs to be added to this product to make it inherently safe. What has happened since then is that the manufacturers who have billions in R&D are developing new products that have realized that product is, not good enough. We need to make it better, and they make it better. And by the time they've made it better and brought it so that it does already have that, the working group is still focusing on how do we fix the old problem, right? And nobody's looking at where the new technology is. And then you get the situation where we're now having updates annually or trying to push for these updates annually, but we are still so far behind. That's why my big push is adopt IEC, adopt UL. That is what we should, because what happens is these manufacturers sitting in China with this 1,500 engineers designing these products at a much quicker rate and a much better rate at what local people can actually, comprehend. They are in constant contact with IEC, but they do not make contact with SANS, because who would care about the SANS working group, a group of 25 to 40 people serving a country which contributes 3% of the global volumes of these big manufacturers? What they are doing is they're looking at, okay, let's get IEC involved. Let's talk to them and see what it is that their requirements are for us as manufacturers to get on board with these products. And then they do that. Now we are saying that we want to cater for the 3%, but we also want to design for the 3% and do everything on our own for the 3%. If we can free up these people, we can maybe, adopt IEC, go down the route in which the manufacturers are actually communicating with, and we can
Fine.
that energy.
To be fair, SAB's working group, SAB's 10142, is doing exactly that. They are writing into the SANS 10142 standard references to IEC standards. They're adopting IEC standards as SANS standard. I want to say this, that I think the global OEMs are doing a fantastic job in ensuring innovation at a fast level and at a high level quickly, as the improvements happening. As you say, the improvements and safety features being built in are happening faster than the standards writers can write standards. And I think they're doing a fantastic job. I think a company like Go Solar is doing a fantastic job in standardization of a residential and commercial installation, standardized design, standardized products, standardized procedures, standardized installations. They talked about how it's the symmetrical layout. It's just got to be done right. And this degree of standardization at all levels, through the IEC standards, through SANS standards, through installation practices, through each installation, by having a whole fleet. This is doing a fantastic job. I think The problems in South Africa's electrical installations do not lie in the solar PV and battery energy storage, even though there may be many that are actually not installed to the highest standards. That's not where the problem is. So that's just my personal view. I don't know whether
ultimately we need to think about getting solar to the masses, right? That is it, and that is
why getting the job done right first time.
And that is why I applaud
Yeah.
these companies that are finding ways and means for the poorest of the poor to be able to get to the access to clean green energy.
Mm-hmm. I want to just turn to. I was going to put this to Huawei, but unfortunately, they're not online at the moment. I mean, a lot was talked about. Where do you put this battery? Do you put it in the bedroom or the kitchen or the bathroom? Obviously not. Do you put it, in the garage? Well, at least it's not in the house. But there's still you've got to look at, where the cars can bump into it and this sort of thing. But would it not be best? And I know that that compulsory standards are the minimum required standard. Good practice goes beyond the minimum. But it's not necessarily legislated. But it should not good practice, if it is possible. If it is possible, good practice. Should we not install inverters outdoors, bolted onto a wall on the outside of a house or on a building, if possible? I'm not talking more about the residential thing, and we can talk to Patrick on this. Should it not be installed on the outside wall, maybe with a lean-to over the top to prevent it, from direct sunlight or rain? But these days, the top level inverters are IP66 or IP67, as you mentioned. They don't have a fan; they're naturally ventilated. They are sealed. Ideal for mounting on a wall, if possible. I'm not saying it should be compulsory, but as a good practice, if you can do it, if you've got a battery that can do it, put it on the outside. Is that not the right approach? Patrick, maybe you can come in here and then we'll go to Anthony.
So we do that more and more, but we mainly do that in estates where the equipment is safe. Yeah. It's not very heavy, so you could break into and then take the batteries and inverters if it's exposed to the street. So there's, from a safety perspective, it makes sense, but you also want to keep the equipment safe.
Yeah, true. Good point. I hadn't thought of that, and I think a point well made. What do you think, Anthony, on you showed how the buildup of gases, in a room, in a garage, in a house, can lead to catastrophic explosions of hydrogen. Whereas putting them outside gives you free ventilations. You're never going to get that buildup of hydrogen at sufficient levels to actually create an explosion if it is mounted outdoors. But point taken about Patrick's about you've got to protect your assets as well from theft, etc. But what are your thoughts, Anthony?
Well, we've been exploring this a lot lately and looking in deeper at all of the specifications of how people try and apply 10400T, how we look at the application thereof. When we look at international specification, the whole placement of the battery, South Africa is very quiet on it in our nature of it, and we do have a very unique environment if you compare us to the Europeans. But as Hans already mentioned in one of his answers, we are very close to Australia, so we could actually learn from them and adopt their practices. If you look at what they highlight in the Australian standard, it's very common sense, basic, straightforward implementation. Do not put it under staircases. Do not put it in an emergency walkway. Do not put it in this place. If it's on a wall that's attached to a living area, make sure it's a firewall. Stuff like that, so that you protect the person and the property, as opposed to this whole thing of you shall put it in a garage. If you don't have a garage, then what? Or you shall put it outside. So the reality is we often need to take a more of a less regulatory approach on this matter, and actually more of a logical approach on this matter, which is to highlight, listen here, if you apply the basis of the Occupational Health and Safety Act, and you can assess this risk to this level, at least make sure you cover and allow that person to safely operate in case of an abnormal situation, deal with this risk. And that's the approach that I've always taken with this, is the regulations are very muddy on this. But if you go look at basic safety principles, you see, okay, what's good guidance we can give somebody? If you take the RSHAC guides you. What does it mean to be safe? It means I protect persons and property. What does it mean to be reasonable in that safety? It means that you take into account the cost, the benefit, the methodology of mitigation, all of those specific aspects of reasonability. And as soon as you take those and you apply those to a battery, you start thinking to yourself, where would be the best place to put this thing? And then you would guide yourself according to that. Because there is no one-size-fits-all answer in South Africa. We've got thatch roof premises, we've got high-rise buildings where we've got people in flats installing alternative energy, which was never designed for that purpose. No flat was designed to have a battery storage system in it. If they did, there would be a storage room built on the side of the flat where everybody could install their units. But the reality is we now have to adapt. And the whole thing is to adapt safely, adjust safely, adopt specifications to guide, not to overrule. And that's where we need to start going. So if you look at what the Australians already have done, I feel it's very reasonable, which is deal with the actual risk thereof. And I feel like we should in some way guide people with that as well, in applying it reasonably.
Bottom down instead of top down, bottom up instead of top down approach. I fully agree with Anthony there.
Yeah, and practical codes of good practice as opposed to prescriptive, legislation or prescriptive regulations that are mandatory. I think a good, a code of practice for good practice would go a long way on just guiding people and installers on better ways of doing things, not
best practice
do them, but just better ways. Yeah, and coupled with training. I want to move on to the question of arc fault detection and circuit interruption. It's been spoken about quite a few times in this discussion. And it strikes me that DC arc faults, which are caused of loose connections, poor crimping, goodness knows what on the installation side, which are all things that happen. We know they happen, aging, poor installation, whatever. Yet, a DC arc fault, first of all, is self-sustaining. In other words, there's no current zeros to extinguish the arc. So if there's a loose connection with that arc will just continue arcing unless you shut down the inverter to create an artificial current zero, at which time the arc can be extinguished. The point is that it's like having a welding torch on your roof. If you have an arc fault in one of the interconnections, it's like having a welding torch on your roof, which can reach several thousand degrees centigrade and create a fire. And we all know that these solar PV panels have these the laminates and things that can present a fire hazard. So once a fire starts, they can rapidly spread across the solar PV installation if these laminates are not fire resistant, which is often the case. The thing is, there is a good technical solution, which is arc fault detection and circuit interruption, where in the inverter it can detect high frequency noise on the DC arc, can shut down the inverter, extinguish the arc, restart the inverter, and hopefully that arc has been extinguished. But if it reignites, the inverter will shut down again quickly, almost like an auto recloser. So it tries to reconnect a few times and then locks out and sounds an alarm, and you get a message on your cell phone that there's a DC arc fault lockout. This technology now is like 2 and a bit years old. When I say the technology is older, but the standard, the IEC standard for this is about 2.5 years old. And it seems to me that this it could be a major way of reducing the consequences of DC arc faults. Is this taking off? I mean, Hein, do your inverters have FC testing as standard, Or what percentage of inverters are you seeing out there that have got this kind of functionality built into the inverter? Is it something that is becoming more and more prevalent or not?
Chris, it's actually it's not just becoming more prevalent. It's that the technology has been existing for quite some time, but we are now sitting on AFCI 3.0. Right, so AFCI was the original one, then AFCI 2.0. Now the manufacturers are now deploying AFCI 3.0. So AFCI 3.0, the sensitivity for arc fault detection is much higher now, which is millisecond shutdown. The other thing that's also happening is the distance over which it can detect it. So AFCI 1 could detect over, I think it was a maximum of about 100 meters, right? So end to end. AFCI 2.0 was roughly around about 300. We are now seeing up to 600 meters in AFCI 3.0, which is much longer than what the majority of the strings are. This is now becoming utility grade AFCI protection that's being built in. And not just that, power line communication over the DC line can actually tell you exactly where the arc fault is. So in other words, it can tell you 200 meters down the positive string is where the arc fault is, which makes maintenance and repairs on this kind of product a lot better. And from my experience over the past years that I've seen, I expected you to just become even better and even better, and even with companies like Shane's company, Huawei. This is inherently what they do, right? They want to make it safer, because if you think about these big companies that are publicly listed, number one, their worst enemy is bad press due to PV fires, right? So they would want to mitigate these things, and the same goes for battery energy storage companies. So AFCI is definitely taking off. AFCI 1.0 or the original AFCI, I would have told you I would prefer an optimizer, right? Because the optimizer goes to zero. And that was, in my opinion, the safest. Yes, it adds a lot of complexity, and we have seen the failures of optimizers because they're these little boxes sitting behind a panel in massive high heat, and eventually becomes, some of you have these failures. So you have the few odd panels down. Yes, the great part about it is if there's a panel that's down, you don't lose all of the production because of an optimizer. But with AFCI now, I think it has surpassed the point where optimizers is your only go-to for safety. AFCI 3.0 is very safe, and I think that this will become even safer in the future.
Yeah. So let's just now bring in Leon and Andre. This is an IEC standard, this FC functionality and testing. It's been an IEC standard for like 2 and something years. Is this something that you're going to build into SANS 10142-1 as one of the reference standards, which would make FC testing a requirement going forward? Should it be incorporated, or should this be left to the customer's decision? Many customers don't know a lot about inverters and safety and FC testing and stuff like this. In the interest of consumers, should this be built into a compulsory standard like SANS 10142-1 or not? Leon, you first.
My answer would be no, because it is mentioned in the 60364 documents, and we try not to duplicate things in the wiring code, purely because we don't want to inflate the document, and it is really not necessary to have duplicated.
So what I'm getting at, Leon, is SANS 10142-1 reference this IEC standard? I don't know if SANS has adopted it as a standard yet, but does the IEC 10142 reference the standard? I'm not saying to write this requirement into SANS 10142, but saying that all inverters should comply with IEC such and such, which includes the FC functionality. Should that not be the case?
I don't know if that would obviously be up to the working group to decide that. In my opinion, the IEC wiring rules are mentioning the AFCI sufficiently, and it does mention when it is installed and needs to comply with the AFCI standard. We are actually adopting a new -7-712 within the next few days, and that is the PV wiring rules. So I think it does cover it sufficiently within that document.
Andre, do you want to come in here as well? Anything you want to add?
Chris, I can see myself and Leon, we're in the same working group, we talk the same language. I think cognizance must be taken of the technology, but choice must remain by market. I mean, if you look at the technologies in cars, for example, seat belts and so forth and so forth, what is this anti-braking, sliding and so on, it's becoming the norm, whereas it was a very optional expensive item, but later when you at the point where you prescribe it, everyone is already using it. So regulation will always be slower than development. Now, I want to tell you that we already have an arc fault detecting device standard in the wiring code. It is called SANS 62606, and that is for arc finding devices in a distribution board. But we don't say you must use it. If you use it, that is the standard. Forget solar. If every DB had such a device, arcing must be the source of most electrical fires. It would be fantastic, but we are not prescribing it. We just say that is a standard if you want to use it. It comes back to the OEMs. They are leading the war in terms of development, and the people offering the products must rather sell more for same, and adding this as you. By the way, you get this as well. So we already have arc detection in wiring installations in the wiring code, but we're not compelling it. It's not necessary. It's not the way the code works.
Yeah, I think that's very, very insightful. And competition amongst OEMs to be better than their competitor, to build in features that they can brag about and be proud of, is a better driver for progress and quicker too than changing a compulsory standard, which is not a quick and easy job, requires a public participation process and all of that. So I think your insights there, Andre, are very, very valuable, and I'm very grateful for that. Colleagues, we've come to the end of this. I would like to, if there are any of our audience that want to put up their hands, I'm watching, I'm only going to take one or two hands up questions, but if there are any in the audience that would like to ask a question, please put up your hands and I will come to you. I don't see any hands up at the moment. Oh, I do now. I see Gerard Selier. Gerard, I'm going to switch on your microphone and allow you to talk. So please, on your side, switch on your microphone. I have, I think, allowed you to, and ask your question, but please introduce yourself before you ask your question. Over to you, Gerard. Gerard, are you there? I see your microphone is on. Yeah, thank you. Ask your question, please.
Good afternoon. Thank you very much. Quite an insightful event that I enjoyed here this afternoon. I'm speaking asking the question from a facilitator, assessor, moderator in SHE training, OSH Act, compliance, etc., environment. And basic firefighting is one of the subjects, and in there, we normally speak about class A, B, and C fires, and then often very cursory about the metals producing their own oxygen type fires. Is there any guidance, any one of the presenters that can lead me later to expand on that? Because this is a new field. We know how to kill paper, we know how to kill flammable liquids, we know how to kill electrical, but the LiFePO batteries, those sort of things pose real risks. And in many cases, in some of the least suspecting places, like schools, they've got lithium batteries in their audio-visual equipment. They get stored. The people are not very knowledgeable. So is there anybody that can, at some stage, maybe just contact with me and give me some guidance on how we can expand that material to make prevention is better than cure. So we can prevent that rather than fight the fire in the school when it happens.
Yeah, Gerard, let's put this to Anthony. Anthony, are you available? I can put Gerard in touch with you, or Gerard, you can contact Anthony at the ECA. Would you be able to guide him on how to protect against lithium fires? What is possible? What is effective and what is not effective? Can you follow that up with
100%.
Gerard?
I can definitely follow that up.
Okay, cool.
Thank you very
Well, let's
much,
leave it at
Anthony.
that and move on to the next hands up question, because time is short now. And I'd like to go to Michelle Rivarola, a regular questioner on our webinars. Can you please ask your question if you are still there? I think you've gone now.
Dropped off.
I think you've dropped off, Michelle. Okay, let's move on to Willem van Skalkwyk. I'm allowing you to speak now, Willem, so please switch on your microphone and ask your question.
Question is the reliance on arc fault detection. I understand that arc fault, the inverter identifies the signature of a non-normal conduction somewhere upstream of it between the source, which is the PV panel, and the inverter itself. Surely, if the inverter disconnects and stops drawing current, it does not in any way affect the short or the leakage that was upstream of it. So if there's a short circuit between the panel and a wire or a junction box somewhere, the inverter then stopping the draw is not going to change that signal or change that current draw. So I think there's an over-reliance in thinking that if you've got arc fault detection, that there's some protection. There's no protection. It just tells you that there's something has gone wrong and there's a short circuit somewhere. Do I have this wrong?
I think you've got that wrong, Willem.
Yes.
It detects it. It's shut down the inverter. The arc is extinguished. The inverter switches back on again. If the arc reestablishes, it switches off again immediately. It does this one or two or three times, and then it locks out and sounds an alarm, so that it actually prevents this DC arc from persisting for any length of time. In fact, as
I think
Hein pointed out, it can happen very quickly. Hein, please come in here and explain.
easy demo is we've all seen the guys taking a PV panel that's in the sun and then shorting the two ends together, which creates the arc, right? And then as you move it out, the arc flashes with it and then it stops. So what happens is when you are shorting them together, you're creating an ISC event. In other words, a short circuit, which means that the current is present and the voltage as well. An AFCI device removes the current to current zero, which means it's got no draw on it and there's no short circuit happening. Because if you look at the string has got a positive and a negative going to the inverter. The inverter basically creates the current draw. When the arc fault detection shuts it down, you've only got the positive or the negative where the arc has happened. You do not have a closed loop, which means that the arc is not present. If that explains it to you, Willem.
Yeah, I
Let's move on to the next question.
If the short circuit is in a combiner box somewhere, it's upstream of the inverter. So there's a circuit that runs outside of the inverter. So whether the inverter completes the circuit or not, there's a circuit somewhere else. So let's say the example that you were explaining, Heine, is that the positive and the negative were shorted somewhere outside of the inverter. So whether it's a parallel connection, it's a parallel switch. You imagine two switches in parallel. If one switch is closed, the circuit is completed. Now, if the inverter is the second switch that's closed, there's still a closed circuit elsewhere.
I mean,
which continues with the spark.
That is exactly why I feel circumventing with adding external components is part cause of these fires. But yes, if the arc is that side, obviously the inverter won't be able to detect it. But if it is in a string that is connected to the inverter, the AFCI is able to shut it down. If the disconnecting switch in the combiner box is shut off and you still have the arc beyond that, there's no way that the inverter can do that protection once you have added that switch or that portion. It's only when that arc is present in direct connection with the inverter that the inverter can actually mitigate that risk.
I understand that. Okay, thank you.
Yeah, I think that answers the question. It doesn't. The arc fault, can protect, arc faults within a string, but not necessarily, across a string. It's not going to be able to shut that down. Okay, let's move to the last question, and I'm going to move back. I'm going to move to Shakes Makwana. Shakes, I'm going to switch on your. Going to allow you to talk. Please switch on your microphone and ask your question, Shakes. I think I've enabled Michelle Ravarola to talk. Michelle, will you ask your question?
Yeah, sorry, just a point on the issue of fire protection. Factory Mutual Global, or FM Global, publishes a huge amount of information on fires, how to fight them. They have data sheets which are freely available on fire protection, and they're certainly focusing on batteries and PV installations because they're the ones who pay for the insured costs. I just have a point that I'd like to raise. I think there's a major amount of negative publicity that is given to PV systems and batteries, like you've seen with EV, with electric vehicles. I mean, there have been millions of installations and hardly any incidents. So if you look at that statistic and you compare that to poorly wired houses and the number of incidents that have occurred because of that and fires because of that, then then you're drawing a proper comparison. But at the moment, saying that batteries are unsafe because if there is a problem with one of the battery cells, you could have a runaway, possibly a runaway fire. I mean, it's just like saying if you have a gas cylinder in your house is likely to be blown up if the cylinder catches a light. I mean, it's a risk. Everything you do is a risk. You've got a plug in your house, that's a risk. So I think it's being grossly overplayed. But one point I'd like to make, I think that eventually in South Africa, we need to take the bull by the horns and start listing equipment for installations, because there is no limit, or there's no requirement for importers of equipment. So you have, one of the most common failures are the connectors. So you can use any connector coming from anywhere in the world without any markings, any tests, any specifications that you want, or that should be required in a proper installation. Yet, if you use the proper connector, there would be no problems with fires that originate at connectors. And similarly, with inverters. You want an inverter indoors? This is the list. The City of Cape Town compiled a list of inverters that they were prepared to consider in their schemes. I don't know why it's so difficult for SABS or whoever is the legislating authority to do a similar thing. You want your inverter installed indoor, these are the tests, these are the specifications, and then you become part of the list. If you're not prepared to spend the money to have these tests and these specifications checked, then you can't use it. As simple as that, and you can't import it.
Michelle, in essence, we have a compulsory standard, SANS 10142, which refers to an inverter spec IEC whatever, SANS IEC such and such. That means you can only use an inverter that complies with IEC such and such, or SANS such and such. For me, if then the regulator for compulsory specifications wants to make that SANS compulsory, it actually is already compulsory in the sense that it is referred to in the SANS standard, and the SANS standard is compulsory. So I think all of this exists, and really it's up to people like Patrick, who install these things on a significant basis. They check that this inverter has got the right, it complies with the right standard. This City of Cape Town list, is nothing more than a check that it complies with an NRS specification, not even an international standard. It's an NRS, it's a local utility specification. I think that's the wrong approach. I think the right approach should be that your inverter should comply with this and that international standard. And then it's up to people like users like Patrick to make sure that they use equipment that actually is certified to comply with that international standard. Look, colleagues, we're going to have to call it a day now. We're over time, and it's been a fantastic discussion with a fantastic set of presenters. And I've learned a lot, and I hope the audience has too. And look, we're not just talking about compulsory standards. We're talking about good practice, which goes beyond the minimum. Compulsory standards, I think, are there to deal with the minimum requirements that you have to comply with. But that doesn't mean to say you shouldn't, comply with good practice, whether it's good product practice, good installation practice, good sign-off and checking and inspections and maintenance processes. These all go beyond the minimum. And I think Andre has made this point very well, that we should be only regulating the minimum requirements, but that doesn't mean to say that product manufacturers and installers cannot set their own higher standards, and they should. And companies like Huawei, like Sig Solar, are doing incredible things quality-wise, incredible things technology-wise, with massive R&D budgets. And companies like Go Solar are doing incredible things locally in terms of standardization and making sure that their installations are compliant in every detail and go well beyond the minimum. And that's, I think, a good approach. And as Andre said, and I agree with him, I think we've got a lot to be proud of in the solar PV and battery energy storage industry across the board, from OEMs to installations and maintenance. We've got a lot to be proud of, because I think it is not the problem. This is not where the problems lie in South Africa, really. The problems lie in the distribution networks of municipalities and Eskom, and the illegal connections there too, which are patently obvious in front of our eyes. We see it every single day, but it is just left to kill people again and again and again. And I get to go out and do investigations on electrical accidents, and I see this happening all the time. And I don't see it happening on solar PV systems at all. I haven't done one where there's been an accident on a solar PV system. So I think this webinar has kind of, I think, highlighted some of the excellent work that has been done in the industry. We've got a lot to be proud of. That doesn't mean to say there's no room for improvement. There's plenty of room for improvement. But let's be positive about the things that we've achieved. As Andre pointed out, this industry has massively contributed to a reduction of load shedding in South Africa at the customer's cost, and not at the taxpayer's cost, through the fiscus. The private sector has come to the table, massively invested in this, and we should be very grateful to them going forward. So with that, ladies and gentlemen, I'm calling it a day. Thank you for your attendance. Thank you for the companies that supported this event, in particular the SABS, Extend Leroux Electrical Engineers, the ECA, Electrical Contractors Association, Heralds Group, Huawei Digital Power, and Go Solar. Thank you for your support, and we look forward to seeing you at our next webinar, which will be announced very shortly. All the best.